Welcome back. Today we'll look at polynomial and synthetic division. And before we get into the topic and procedures, I want to make sure we review long division. So long division, you may remember from a long time ago, if you had 2,467 divided by 5, your 2,467 would be inside your fraction bar, and 5, which is your divisor, would be outside. So 5 is the divisor, and that 2,467 is your dividend. Now remember, for long division, you're going to multiply 5, by 4 to get as close to 24. We're going to subtract going down, and then we have to bring the 6 down. And then we're going to multiply by 9, because that's as close to 46 as we can get. Subtract, carry down, 3, and we'll have a remainder of 2. So this will be, I'll just write it over here. So 2,467 divided by 5 will equal 493 and 2/5. So when I look at this, this is the dividend over the divisor equals the quotient plus the remainder over the divisor. Another way to write it is to say, well, what's 2,467 equal? Well, if I multiply 493 by 5 and then add the remainder, I'll get back to 2,467. So remember, that's the dividend, that 2,467. Our 5 was the quotient, or it was the divisor, and 493, I'll just put in parentheses, with our quotient, and then our 2 was the remainder. So there's really two ways that we could write that equality if we're going to write that later. But again, the answer, and I shouldn't be really clear, if it just said divide this, right, you would have just said, well, the answer is 493 and 2/5. So if we said divide it or simplify it, you would just give that answer. But in general, I want to make sure we're clarifying what's the divisor, what's the dividend, what's the quotient or remainder. Because when we have polynomials, they start to all look the same. So you can actually see right here, here's the first way I wrote it. The quotient plus remainder over divisor would equal that function divided by the divisor. And then the second way is up here. The dividend equals the divisor times the quotient plus the remainder. Now when we look at fractions and rational expressions, we actually use the same terms that we use for fractions. We can call them improper or proper. So an improper fraction, when you would cover improper fractions, would be when the numerator was bigger than the denominator. An improper rational expression would be when the degree is higher in the numerator than the denominator. A proper fraction is when the number is less in the numerator. And a proper rational expression is when the degree is higher than the denominator. Now let's do some division. Before we get too far, make sure that you always write the dividend and the divisor in descending order of degree and powers. If there's any degrees missing or variables missing, make sure you put placeholders with 0 coefficients. Okay, let's do some division. Inside, under the bracket, we're going to put 6x to the 4th minus x cubed minus x squared plus 9x minus 3. And you can tell it's going in descending order, nothing's missing. 4, 3, 2, 1, 0. We're going to divide that by x squared plus x minus 1. Now remember, for the first step, you want to say, what do you need to multiply x squared by to get 6x to the fourth? Well, we need a 6, and we'll need 2 more x's. So that'll be 6x to the fourth plus 6x cubed, we have to multiply by the x, and then minus 6x squared. Remember, we're going to multiply, or sorry, we're going to subtract going down, so the terms cancel. So we'll have negative 7 x cubed plus 5x squared, and then bring down the 9x. Now we need to look at that negative 7x cubed. If we multiply by negative 7x, we'll get negative 7x cubed. And this will be negative 7x squared, and then plus 7x. Subtract going down, so we'll have 12x squared plus 2x minus 3. Now we have to look at that 12, and we need to multiply that by 12 to get to 12x squared plus 12x minus 12. Again, subtracting going down, so we'll get negative 10x plus 9. So you can see that this will equal, and I'm going to write it out here, 6x squared, or sorry, I'll write it out, 6x to the fourth minus x cubed minus x squared plus 9x minus 3 over x squared plus x minus 1 is going to equal 6x squared minus 7x plus 12. That's our quotient. And then plus the remainder over the divisor. So plus, it'll be negative 10x plus 9 over x squared plus x minus 1. Remember, this was our remainder. And so our final answer would be this fraction, or this polynomial. Okay, now let's divide x cubed minus 2x squared. And you could notice there's no x, so I'll put 0x minus 9. We're going to divide that by x minus 3. So we're going to have to multiply this by x squared. So we multiply that by x squared, and we'll have x cubed minus 3x squared. Subtract going down, so we'll have x squared plus 0x. Now let's multiply that by x. So we'll have x squared, and here we'll have minus 3x. We're still subtracting going down, so this is going to become positive 3x. And bring down that minus 9. And we can multiply that by 3, and we'll have 3x minus 9. If you notice, this has a 0 remainder. So if it has a 0 remainder, that means that this polynomial was a factor. Okay, so this is remainder 0. So we can pretty much write the answer as x squared plus x plus 3. Now let's look at synthetic division. Synthetic division may be a lot easier. The process isn't too hard, so I want to make sure that we go over that before we look at some of these problems. For synthetic division, you have to look at the 0. And the 0, the factor that we're looking at, needs to be a linear factor. So if you notice this k, this 0, is going to be pretty much the multiplier. We're going to be multiplying by that number. The process is we're going to actually be adding the columns, the terms in the columns, and multiplying those results by k. So let's look at this one. We're going to divide by x plus 2. So that means our k, or 0, is -2. So I'm going to put -2 in this multiplier box. On the first row, I'm going to write the coefficients of the terms and the constant. Remember, if there's anything missing, I would put a 0. But nothing's missing. 3, 2, 1, 0, right? So looking at those degrees. So the coefficients are 5, 8, -1, and 6. Now the process is add going down, but there's nothing to add the 5 with, so I'm going to bring that down. And then I'm going to multiply the 5 with -2. So we get -10. We're still adding going down, so that's -2. -2 times -2 is 4. Adding going down, we get 3. -2 times 3 is -6. Add going down, we get 0. I always put that last number in our box because that tells us the remainder. And here the remainder is 0. So that means that x plus 2 goes into that polynomial evenly and is a factor. So when I divide that by 1x, I essentially took the degree of x. So these new numbers are going to be my new coefficients and constants, but instead of x cubed, I'm going to start off with 5x squared minus 2x plus 3. And we completed our synthetic division. For the next one, we have 2 is going to be our k. I'm just going to use a different color so they don't go together. So I'm going to put 2 in the box, the multiplier box, and then I'll put the coefficients. We have degrees 3, 2, 1, 0, nothing's missing. So it's 1, 1, -17, and 15. I bring the 1 down, multiply that by 2, add going down, 6, -12, -24, and 9. That'll be -9. So that's my remainder. So -24, it wasn't -15, so we're definitely going to have a number there. So this was a third degree polynomial. We removed one of those x's. So essentially we're going to have x squared plus 3x minus 12 minus 9 over x minus 2. We have that remainder. So our quotient, I'll put it right here. The quotient is x squared plus 3x minus 12. And the remainder is -9. Now let's look at some more. For this one, our k is going to equal -3. So I'll put -3 in the box. My coefficients are going to be 2, 7, and I'm missing one. So I'm going to have to put 0 there. So 2, 7, 0 for my x, and -5. Bring down the 2, I get -6. Add going down, multiply going up, right? So that's -3. Add going down, 9, and a remainder of 4. So it was a third degree polynomial, it was a trinomial or cubic. Took away a degree, so it's going to be 2x squared plus x minus 3 plus 4 over our divisor, x plus 3. Now let's look at the next one. For this one, our k is going to be equal to 2. So I'll put that in the multiplier box. And our coefficients are 4, -3, 1, 7, constant 7. Bring down the 4. Multiply going up, so that's 8. Add going down. Multiply 2 and 5 makes 10. Add going down. 2 times 11 would be 22. Add going down, so that's 29 is the remainder. So this will equal 4x squared plus 5x plus 11 plus 29 over x minus 2. Okay, now let's look at when the divisor has a coefficient that is not equal to 1. So you may see right here, you could probably figure out pretty quickly that our 0 is going to be 1/2. But we need to make sure that we actually make this 1/2. So I'm going to divide everything in this whole equation, this whole quotient, by 2. Because I want to have that that coefficient for the x, the linear factor, to be equal to 1. So we're going to have 4x cubed plus 6x squared minus 2x minus 3 divided by x minus 1/2. All right, so right here, I can see that my k will be 1/2. And now my terms, my coefficients will be 4, 6, -2, and -3. I'm going to bring down the 4. And then multiply the 4 by 1/2, so we get 2. Add going down, we get 8. 8 times 1/2 is 4. 4 minus 2 is 2. And then half of 2 is 1. So we get a remainder of -2. So remember, we're eliminating one of the x values, one of the factors. So we'll have 4x squared plus 8x plus 2 minus 2 over x minus 1/2. Now we want to just clean that up a little bit. Okay, so for the remainder and that divisor, we're essentially going to multiply this whole thing by 2 over 2. We're going to get back to what originally was the divisor. So nothing changes with the first part, okay, with the quotient, but then we'll have minus 4 over 2x minus 1. Now let's go to another one. So for this one, we're going to divide everything by 6. Lots of 6's there. So we'll get 2x cubed, and this isn't going to be easy fractions either, but this will be 19 over 3 minus, what's that going to be, 8 over 3, x minus 10 over 3 divided by x minus 5/6. Again, 5/6 will be our k, our multiplier. Using the coefficients 2, 19 over 3, negative 8 over 3, and negative 10 over 3. So let's first bring down the 2, and we're going to multiply that by 5/6. So we essentially get 10/6, which can be reduced to 5/3. Add going down, we get 24 over 3, which is 8. Now 8 times 5/6 would be 40 over 6, which equals 20 over 3. And that'll be 12 over 3, which equals 4. And then 4 times 5/6 would be 20 over 6, which would be positive 10/3. And we'd have a remainder of 0. So eliminating one of those x values, we'll have 2x squared plus 8x plus 4. All right, now let's use the remainder theorem. So the remainder theorem is really fun because you can actually find and evaluate functions using synthetic division. So if we know the remainder, we can actually evaluate these functions. So let's evaluate and find out what f of negative 4 equals using the remainder theorem. So we're going to make negative 4 our k, and essentially it's that multiplier. So I'll put negative 4 in the box, and the coefficients are 4, 10, negative 3, negative 8. Using synthetic division, I'll bring down the 4, multiply, add going down, multiply with negative 4, add going down. This is going to be negative 84, so negative 92. This remainder is going to be equal to f of negative 4, because the remainder is going to, this is what the remainder theorem says, the remainder equals f of k. Now let's look at the factor theorem. The factor theorem states, if a polynomial f of x has a factor x minus k, if and only if f of k equals 0. So what we want to do is factor x cubed minus 19x minus 30 and make sure we show that x plus 3 is a factor, then find the remaining factors. So if we have x plus 3, our k will equal negative 3. I'll put that in the box. Our coefficients are going to be 1, 0, negative 19, negative 30. Don't forget, this was missing an x squared. So I'm going to bring down the 1. This is negative 3. Add going down, multiply, negative 10, positive 30, and yes, the remainder is 0. So since we know that f of negative 3 equals 0, x plus 3 is a factor. Now we know that this was a cubic. We divided by x plus 3, so we have x squared minus 3x minus 10. Now we know we can factor that because two factors that multiply to make 10, negative 10 add to make negative 3 are negative 5 and 2. So we can actually write all the factors for this polynomial. It was x cubed minus 19x minus 30, and that'll be x plus 3, x minus 5, and x plus 2. So those are all the factors of that polynomial. Now let's look at this one. Our divisor is going to be x plus 1, so our k is negative 1. So I'll put -1 in the box. And our coefficients and constants, it'll be 1, 2, -5, and -6. Bring down the 1, we get -1, add going down, and then we get 6, which is 0. All right, so this is going to be x squared plus x minus 6. And we know that that can factor. So I'm just going to write this all down. So x cubed plus 2x squared minus 5x minus 6. Well, we know that x plus 1 is a factor because when the remainder was equal to 0. So that's why x plus 1 is a factor. That's using the factor theorem. And then we have x squared plus x minus 6. Well, we can factor that so that we get x plus 3, x minus 2.